Hey, John Holman again. Thanks for watching this video. All right, this one is for anyone who's ever stared at a back test at 2 a.m. and thought this damn thing is either a genius or going to wipe us all out. Like I said, I've been working with a small AI-focused lab myself and 4 AI persistent personality teammates. And we've been building training data that changes model behavior, especially around risk, uncertainty, and not lying to you about what it doesn't know. So in this video, I'm going to show off our finance pack in action, baseline model on one side, same model with our finance data plugged in on the other, and we'll see how it talks about risk and models when it actually has some decent context. See you in the next one. Okay, real quick, here's the setup. On the left, we've got a normal baseline model. On the right, same model, same weight, same GPU, but with a curated finance node pack attached. It's a few hundred high signal nodes distilled from papers and books on portfolio theory, risk models, and real world finance. So the only thing that's changing here is the data we let it read while it answers. Okay, here we go. Describe an example where model overfitting looked great in sample, but then failed out of sample. All right, overfitting, the oldest enemy. On the baseline side, it's the classic definition, train great, fails on new data, which is true, but it's basically the model saying overfitting is when your model overfits. Helpful, thanks. Now look at the ADS side. Same model, but with our finance pack attached. And it actually gives a specific story, AMM pools and this RVR model idea. That's the real finance version of overfitting. Your back test looks like a superhero, and then it meets the real world and becomes normal guy immediately. And the receipts are right here. The context bullets, climate risk with negative jumps, tails matter, shocks happen, network vulnerability, systems look stable until they don't, and the RVR AMM bullet, that's the concrete anchor for the example. And then down here, you can see it use 3 nodes. Baseline took longer and rambled more. ADS stayed tighter because it had real context to lean on. So basically, that baseline explains the concept. ADS shows you where it's going to bite you. See you in the next one. Okay, question 2. How should you treat non-stationary market regimes when designing an algorithm? All right. So on the baseline side, it gives a standard playbook. Use something adaptive, maybe ML, maybe a Kalman filter, or a hidden Markov model. That's the kind of answer that sounds correct. It also sounds like it came from the first page of a quant interview prep guide. Now look at the ADS side. Same model, but it's reading from our finance pack while it answers. And the key is right under wisdom context. It pulled 3 specific anchors. First bullet, a reminder that online learning in markets has hard limits, even under nice assumptions. Basically, don't assume you can just learn your way to an edge forever. Second bullet, a concrete method, adaptive minimum risk rate, AMVR. It explicitly talks about convergence towards minimum variance behavior under heavy tails and non-stationary dynamics. That's exactly the kind of detail the baseline never gives you. And in the third bullet, it points to a modern angle using a generative foundation model to simulate market conditions at an order level engine to stress test the behavior across regimes instead of trusting one backtest. So the difference isn't that ADS is smarter in a vague way, it's that it's grounded in specific ideas and it's forced to acknowledge the reality of regime changes, tail behavior, and evaluations. And you can see it in the metrics too. ADS used 3 nodes, and it's doing the thing we actually care about. Not just be adaptive, but here are the approaches and constraints that show up in the literature. Baseline says be adaptive. ADS says here's what adaptivity can't do. Here's a method that handles heavy tails, and here's how you stress test it across regimes. Okay, last one. When are factor models misleading in real-world markets? Okay, look at the baseline answer on the left. It's basically saying they're misleading when the assumptions don't hold, which is true, but it's also the kind of answer that makes you want to ask, cool, and Which assumptions are those and how do they break again? Now look at the ADS answer on the right. Same model, but with the finance pack attached, and it gets more practical. It calls out that markets don't act like neat little spreadsheets, that information isn't evenly distributed. Behavior changes under stress, and relationships you thought were stable often stop being stable. That's the real reason factor models can get you hurt, not because the math is dumb, but because the world stops behaving like math. And these bullets right here are the context it used, the actual snippets pulled from our finance notes. And you don't have to trust my narration. You can literally see what the model read while it answered. And then down here, you can see that it used 3 nodes for context. Baseline is faster and generic. ADS takes a little longer because it's grounding the answer in real material. And that's the whole point of what we're doing. We're not trying to sell you a magic model. We're selling better training data so your models stop sounding confident and vague and start sounding like they actually respect uncertainty. So run it yourself. If it's real, you're going to see it. And if it's not, you'll know even faster. That's the deal. All right, back to work.